Okay, so now we're on stage.
Yeah, I see a screen. I think we can maybe start.
Perfect. Okay, guys, thank you for joining this session. We're very, very pleased to welcome Softplan here to show what they've done with their platform, which has been on BricsCAD for over 10 years, but we internally haven't seen that much of it yet. In general, one of the main things we like to emphasize and encourage is development on our platform. So seeing something as sophisticated as this, in particular for water and sewage networks, is really, really encouraging. So I can talk more about the BricsCAD side at some other session. Today, really, I don't want to take up too much time because we've got so much information to show. So let's welcome these guys to the stage and sit back and admire the software.
Okay, Sean, thank you very much. Just a very, very brief intro. So obviously Softplan is an add-on software for BricsCAD Pro, and is specifically for the design and calculation and analysis of water and sewage networks, and based on BricsCAD Pro. And so today we'll be showing water network design and calculation and analysis live in just a few moments. So I just want to emphasize, so primarily the software is about design, so layouts, plans, profiles, cross sections, trenches, clashes, all these things. But it also includes EPANET for hydraulic modeling, and there's also actually a set of analysis functions, data tables, thematic maps, queries, and various stuffs which you are maybe more accustomed from GIS tools. So just a very simple question: why choose BricsCAD Pro and Softplan? So first, CAD power, obviously. So BricsCAD is a really great platform. It's very fast. It's very stable. It's in development all the time. Great features coming up, and Softplan is much the same. So we put a lot of work in development. We focus just on pipe networks. And so there's really lots of options to do this. Flexible licensing is important, I think, today. So as well, with BricsCAD and with Softplan, you have a permanent license, you have a rental license, you have single, and you have network. So you choose what you need and what fits best for you. The price performance ratio is actually very good when you compare it. So you need, it's not just how much it costs, but you have to look how much value you're actually getting, how much time you're saving, how much money you're saving by not having to rely on additional tools. Because there's lots of stuff you can do with this great package. So the price performance is really great. And then development that delivers. So both BricsCAD and Softplan, we both emphasize a lot on development. We have development plans to deliver new features, to improve old features. So we constantly improving, and these improvements they're getting to our users. Again, for both companies, it's true. Several times a year there's updates. So this is a product that is delivered all the time. And last but not least, support that cares, that you can count on, that will not leave you with your problems, but that actually, you know, there are some people who you can write to, and they actually respond. They want to help you. So that's you know, I think it should be the standard way, but unfortunately, many software companies don't think like this, but we do, and I think that's important. So enough about these things. I would like to invite now our head of the development, Mr. Rino, to show you the software live. And so, Rino, please take over.
Thank you, Sean. Thank you, Michael, for your introduction. Hi and hello to everyone. My name is Rino, and welcome to this Planeo Softplan presentation. Today's topic will be Wetplan, our software for water distribution network design, analysis, and hydraulic calculation. In the following 50 minutes of live presentation, I will show you full workflow from the creation of the network in plan and profiles to hydraulic calculation and exporting of 3D BIM model to IFC. So let's start with the live presentation. As you can see here in this drawing, I have only this raster image of this area, but also if I open BricsCAD Layer Manager, here I have some additional layers, these DTM layers that I will now turn on, containing these source elements that I use to create two DTM surfaces. So these are just 3D points and lines with elevations. So using those source elements, I created one BricsCAD DTM, which we can see here, these triangles, and also using the same source elements, I created Softplan Terraform DTM. So this is our own DTM modeler. So if I apply the surface style, you can see that these triangles are basically identical. So it's up to you if you want to use directly BricsCAD DTM, or you can use our own Terraform DTM surface. Okay, so let's go back to plan view. And let's open again this BricsCAD Layer Manager. I don't need this DTM style showing, so I will turn off that layer and also these layers containing the source elements. But I will turn on these layers where I have these helping lines and points that will help me to design my water distribution network. But before we go to designing, I would like to show you one more thing, and that is, even if you don't have the map, even if you don't have the elevations, you can always download it directly from Google Maps. So if I open the function for Google Maps import, I can select the area directly in CAD by defining the coordinate system. So this is in Croatia, so I will select Balkans Zone 5, which is our coordinate system. Then you can select existing polyline, or you can draw the area, which I will do here. So just draw a polyline where you would like to download maps and also points with elevations, which you can later use to create your DTM surface. Now, by defining the zoom factor, you can define number of maps that will be downloaded. So if the zoom factor is lower, then you will download less maps, and also the quality of the pictures downloaded will be poor. But if you increase the zoom factor, you will see that the number of maps that will be downloaded will be higher, and also quality of the pictures will be better. So let's download 4 maps. Additionally, you can create clipping boundary according to that polyline that you draw or selected, and you can choose what you want to import. So is it just rasters, just points, or rasters and points? So I will go with both. And now when you click import, in a matter of 5 to 10 seconds, we will get all these pictures, these rasters downloaded, and also these 3D points with elevations that you can use to create DTM surface. So we can check the rasters. They are of very good quality because we downloaded 4 rasters. And also if I go to 3D, you can see these points that, like I said, we can use to create either terraform or BricsCAD DTM surface. So let's go now back to plan view, and let's go back to layer manager, where I will now turn off this Google layers, because like I said, we already have DTM, which is much more precise. Okay, so let's now start with designing of this water distribution network. Here I have some helping lines and points that I will use. So this will be the position of our water tank. This will be the pipeline from the tank to this water distribution network. And this, where I have these existing polylines, we will use those to convert to Softplan elements. So these are basic BricsCAD 2D polylines. Okay, so let's start the first command for drawing, and that is interactive drawing in Plan, where you can set up many different options. For example, you can automatically label the nodes and sections that you are going to draw. You can choose the source of terrain elevations from DTM surfaces, and like I said, you can go with BricsCAD, Terraform, or you can even use 3D face elements created with some third software. In this example, I will use our own Terraform module. Okay, so additionally, you can define pipe elevation on a constant depth below terrain, and from the pipe catalog, you can select pipe. So I will use, for this main pipeline, I will use PEHD 315 millimeters. So now when I click draw, I will just turn on the BricsCAD OSNAP to snap to the centers of these helping circles. And notice in this tooltip how the elevations are being automatically read from the selected DTM surface. So let's connect here and notice how the labels are being automatically done. So we have, for the sections, we have lengths, diameters, and pipe materials. And for the nodes, we have terrain elevations and invert elevations. Okay, so the next thing would be to convert these existing polylines to the network. So this can be lines, this can be 2D or 3D polylines. Let's open the next function, which is conversion of CAD elements. Here I will leave all the same options as in the previous dialog, but I will use a little bit smaller pipe for this distribution part of the network. Again, PEHD pipes 160 millimeters. This is a great function because you can use layer filtering. So you can just select the layers from the list, or you can pick them in plan. So for example, I will select these elements. The software recognizes which layer this is, and now I can freely select the entire drawing, and the software will select only those elements on selected layers. And now when I click convert, everything will be converted from plain BricsCAD polylines to intelligent Softplan objects consisting of nodes and sections. Okay, so now we don't need these helping polylines and texts anymore. So let's again open the layer manager, and I will turn off these layers. Okay, the best way how to analyze Softplan networks is always by using data tables. And you can see here in the workspace that each function in Softplan, so data tables, labels, profiles, thematic maps, cross sections, basically everything can have multiple configurations. So these configurations are basically sets of predefined data, settings, and options saved for each function. So if I open now these data tables, you can see that I can choose between these previously defined data configurations. So for example, let's select section geometry. And now I can preview the entire model, or you can use these intelligent selection options to select just some parts of the network. Of course, you can select nodes and sections. So section is basically a pipe. So now if I select just these 3 sections, I will get just those 3 shown in my data table. But also we have much more intelligent selection options. For example, selection of branches. Now you can see what is a branch in Softplan. So basically everything in between two main nodes. So starting, ending, or branching nodes. So if I select this one, and this one, I will get all the sections that belong to these branches, but also I can switch to a different data configuration, branch geometry, where I can see the total data for the entire branches. Also, we have something that we call arrays, and these arrays are basically arbitrary topology elements that the user can create by themselves. You can merge them, you can split them, but by default, one array is one original polyline that you used for conversion, or this one run that you draw interactively. So for example, if I select these two arrays, we will get all the sections and all the branches that belong to these arrays. And again, you can switch to array geometry data table, where you see the total data for the entire array. Like I said, you can merge them, you can split them. So let's do that. Let's go to editing of the arrays, and I will use merge option to merge this one that we draw interactively and this one that we got from the CAD conversion. Let's merge them to array A1, okay? And now notice in the data table, when I go to selection of the arrays, this will be one array. Okay, now if I select the entire network, you can see all these arrays here in the data table, and these data tables can be used not just for data previewing, you can also use it for data editing or data inputting. So all the white cells can be used directly from the data table, so you can double click inside and you can change or set the data. So for example, all the array names can be changed directly through the data tables. But for renaming, there are always better ways how to do it. So I like to go to this rename automatically function, and I will select first this for horizontal arrays, and I will just give it a prefix h, okay, like this, and click apply. And for this, for vertical ones, I will select them and I will give them a prefix v. So basically you can rename them however you want. We have some other renaming options as well, but I like this one here. So now if we check it, we have the array A1, then these 4 horizontal ones and 4 vertical ones. So now that we know everything there is to know about Softplan topology and selection options, let's go to draw of the profiles. So to draw profiles in Softplan is extremely easy. Basically, all you have to do is select a profile configuration where everything is stored, from the data to the scale to the language, basically everything. So just select it. And now you can select the entire network. And here you can choose how you want to draw your profiles, according to branch or according to array topology. I will go with arrays, and here you can see these names that I used, these names that we renamed are arrays. And now we can group these profiles. I will put them in 5 rows and 2 columns. And now when I click draw, all I have to do is select the insertion point, and with just one click of a mouse, we have all these profiles drawn. Another great way how you can draw your profiles is by using selection option from node to node. So you can go basically from any node to any node in any direction. I will go through this node all up to the last node of the system, and I will draw this profile here. Okay, so let's now check these profiles. So these are default configurations from English installation, but everything that you see now in this profile, so all the colors, all the data in the data table, basically everything can be changed to look completely different. So to edit the visual appearance of your profiles, we have to go to edit profile configuration. And because there is so much data that can be edited, we have this really nice interactive select function with which you can select any part of the profile. So either graphical or from the data table. For example, let's select this terrain line. The software will take you exactly where this data can be changed. So, for example, let's change this terrain line from this green color to, I will use this brownish color, like this. And when you click OK, your profile will be edited. So using these options, you can basically change everything. And now I will just show you how different these profile configurations can look like. So basically, you can have multiple different configurations in your drawing, and if necessary, you can easily change the visual appearance of your profiles by changing the configuration. So just imagine if you have one profile configuration for designing process, one for plotting, or let's say one another when you are designing for some abroad market in different language or something like that. So I will just select this profile here, and I will change definition from this default from English installation to this German one. And now you can see everything looks completely different. All the texts are in German. We have different color. We have different data. Okay, let's now change it one more time. And now I will use this one. This one is from Greece, from our users from Greece. And now you can see again completely different data, different visual appearance, different colors, and also much larger scale. So now this profile is one-to-one with the plan view, and these default ones are 10 times smaller. So I will return this big one now to the default configuration, but this is just something I wanted to show you, that basically everything can be customized. Okay, let's now take a look at our pipe elevations. So we defined the pipe elevation to be on a constant depth below terrain, which is a great starting solution for water distribution networks. But if you need to precisely define your pipe elevations, you can do it in many different ways, including editing it directly in profiles. So there is also one very nice function that you can use, and that is drawing of the auxiliary elements, terrain parallels. So I will draw terrain parallels for all the profiles, with one terrain parallel at 1 meter and one at 3 meters below terrain. So now when I click draw, you will get this helping polylines that will tell you, for example, if somewhere your pipeline is too shallow or too deep below the terrain. So here, for example, I have one such issue, and now I will show you how you can precisely define the pipe elevations. So the first way how you can do it is, of course, by using these data tables. So let's switch back to section geometry, and let's select this profile here. So like I said, you can use these data tables by just editing this white data, which is starting and ending invert elevations. But there are always better ways, and I like to do it directly in profiles. So I like to use this input and edit pipe elevations, where you have two editing modes. First one is by line, and second one is by slope. So you can select the entire profile, or you can just select some part from node to node. So let's go from this node to this node here. And now you can see this temporary graphics that is showing you how your pipe will look like after editing. So by editing by line, you can define starting and ending depth or elevation. Or if we go by slope, you can define starting or ending depth or elevation and slope. So let's change this slope. Let's round it to exactly -5 promiles. And now you can see how your pipe will look like after editing. So let's say I like this solution. So let's click apply. And now notice that the profile updated, the data tables updated, and also the data in the profile table also updated. So we have a constant slope now here. Okay, let's now switch to by line, and let's select this following part from this node to this node. So I would like to increase the depth here in the ending node. So let's change the depth here from 1.5 meters to 2 meters. Okay, again, we can see how this will look like. And when we click apply, everything is edited, and we see that we resolved this issue here. So using these functions and also many others, you can precisely define your pipe elevations. But let's say for this example here, this will be our final solution of pipe elevations. The next thing that I would like to show you is how you can define and set air release and washout valves. So to do that, we have to go to Wetplan panel. So this is a place where you have all these functions related to hydraulic calculation and modeling. And the first function that I will show you is setting of air release and washout valves. So of course, you can interactively select some nodes in plan or in profile and just define them to be air release or washout valves, or you can use automatic function by selecting the entire network and just clicking apply. So how this function works is the function is basically searching for the highest and lowest inflection points in the network. So basically where the slope is changing from positive to negative or from negative to positive, and is automatically placing this air release at the highest points and washout valves at the lowest points of your network. If we zoom to those same nodes in plan, you can see that the software automatically changed this custom block to show you also in plan the positions of air release and washout valves. Now, this is not essential, it's optional, but if you want, you can place those equipment to be in some kind of a manhole as well. So let's go to function for setting of the manholes, where you can choose many different types of the manholes from the manhole catalog. So different shapes, different sizes, different materials. I will select this rectangular manhole and I will select the entire network, but I will use this really nice node type filtering to select just air release valves. So let's click save. And now you can see that these air release valves will be inside of a manhole. Let's repeat the same thing for washout valves and let's click save. So now where we have air release and washout valves, we have manholes, and everywhere else we have just plain node. Also, if we go to the plan view, you can see that the visual appearance also automatically changed because we are using the 2D styling where you have the real dimensions of pipes and manholes. So these blocks are now gone. Okay. Additionally, what I like to do is to place these main nodes, so the nodes where we have branching, to be inside of a manhole as well. So let's do that. Again, I will select the entire network, but this time I will use a little bit different filter to select just these main nodes. So let's now click save and notice that all the main nodes, so all the starting, ending and branching nodes will be also inside of a manhole. Okay, so at this point, I would like to now switch drawings. But you will see that basically this is the very same project, but here I have some stuff predefined so we can move a little bit faster through this presentation. So let's zoom to the first node of this system, and here I will define a water tank. So it is important to say that this Wetplan module works with the EPANET engine that is built inside the software. So when I open this hydraulic node equipment, you will see here in this drop-down list that you have all the EPANET available equipment, such as reservoirs, tanks, emitters, valves, pumps, and so on. So let's select this first node, and from the drop-down list, I will select a water tank. Here you can edit all these properties, but I will leave it as default. So now when you click apply, you see that the custom block for the water tank automatically appeared both in plan and in the profile as well. So the next step would be to define water demands. So let's do it. Let's open the water demands dialog, where you can use many different methods to set water demands. I will show you two most commonly used methods. First one is automatic, so-called percent calculation, where you can select the area from the plan. You can use the standard Softplan selection options, or you can use CAD selection. So with CAD selection, I will select all this distribution part of the network. So where all the water demands will be defined. And now for that selected area, you can define water consumption per inhabitant in liters per day per one inhabitant. Let's say 180 liters per day. And you can define actual number of inhabitants living on that selected area. So let's say 5,000 people. Okay. Additionally, you can define design period and coefficient of variation per day and per hour. And the software will calculate specific flow in liters per second per 1 meter of length of the section. And when you click save, those flows will be distributed to all the nodes in the selections. Now, we can also define water demands using the standard way, which is basically point demand. So if we go to selection of nodes, you can select some nodes in plan or in profile like this. And now you can set the same value to all the nodes in the selection, or you can use this data table to set different values for each node in the selection. I will reset this because I would like to set just one point demand here to this node. And here it will be some kind of industry. So I will say 6 liters per second in this one node. And this will be our basic water demands to run hydraulic calculation for this network. Of course, we could go to hydraulic calculation according to existing diameters. But if you remember, while designing, while drawing and converting, I defined those pipe diameters pretty roughly. So for this part that we draw interactively, I said everywhere 315, and for the bottom part we said everywhere 160. So I will not go with hydraulic calculation according to existing pipe diameters. Let's go to pipe optimization to get the optimum pipe diameters for the defined water demands. So this function is using genetic algorithms to search for the optimum diameters based on the target velocity that can be defined. It is recommended to divide your network into some kind of zones or groups, which I already did. So I defined one zone to be this transport pipeline, where we don't have the water demands, and distribution network, where we defined the water demands. Now, for each zone, each group, you can define target velocity as a single value or diameter dependent value. And also for each zone or group, you can select pipes from pipe catalog that will be used in calculation for that group. So now when you click start, like I said, software is using genetic algorithms to search for the optimum pipe diameter so that the real ending velocity in the pipes is as close as possible to defined target velocity. So let's save these results and let's analyze it a little bit. So like I said, you can always view the entire network, or you can use selection options to select just some parts of the network. So for example, let's select these two arrays and let's check the results. So this is the ending velocity in the pipes, and this is the target velocity. So we can see that for this first part of the network, we get the optimum pipe diameter, so basically perfect solution where the difference between the velocities is 0. But this is very, very hard to achieve, basically impossible to achieve on the whole network. But we can see that on the other parts, we also have really, really nice results. So I'm pretty satisfied with this solution. If you're not satisfied, you can continue editing the pipe diameters manually. So let's close this and let's now check the results. So you can see that the complete model automatically updated. So now we can see that we have these head elevations showing with these piezometric lines in the profiles. And also if we take a look at the plan view, we can see that this plan 2D styles automatically updated. You can see that the labels also updated, and basically everything is completely dynamic. If we want to put those hydraulic calculation results in the labels as well, we can do it by just changing the label configuration. So for the sections, I will use this configuration with flow and velocity data, and I will apply it to the whole network. And for the nodes, I will use this one with head elevations and pressures. Okay, so let's take a look. And now you can see that we have the hydraulic calculation results showing in our labels. If this happens, if you have overlappings of your labels, this can be also resolved pretty easily. So you can go to interactive move label function and move each label manually, or you can go to this automatic label reposition function where you can define some rules for moving of the labels. And when you click automatic moving, you can see 8 labels that were overlapping were moved, so there is no more overlapping in the entire drawing. Okay, like I already previously said, the best way to analyze the results and basically any data is by using the data tables. So let's open the data tables. I will select the entire network, and let's switch from section geometry data to section hydraulics data. And let's sort it by velocities. So we can see that we have some very small velocities, but they are happening on this dead ends part of this branching network, which is not that problematic because later on we will also define some firefighting demands. And if we check, the highest velocity in the network is around 0.80 at this position here, which is great solution for the defined pipe diameters. Okay, let's now also check the pressures in the network by switching to node hydraulics data table. And we can see that we have again some very low pressures, smaller than 25, that are happening here close to the water tank, which is again outside of our main water distribution area. So this is not an issue as well. But if we take a look at the highest pressures, we can see that we have some very high pressures, so larger than 70, happening here in this bottom part of the network because of the very steep terrain that we have on this area. Another great way how you can analyze your hydraulic calculation results is by using thematic maps and pressure contours. So let's apply for the sections this velocity theme map. So just click show, and for the nodes, let's apply this pressure theme map. Okay. Additionally, I will also apply these pressure contours, and of course you can define these color ranges by yourself. You can define the ranges and also the colors, but I like to use it default ones, because if you're using the default ones, then the colors and the ranges will match those legends that we already have from the thematic maps. So now when we click draw and save this, we have these contours showing us different ranges of the pressures. We can also go to 3D view and check these different zones of pressures. Okay, let's go back to plan view. And now using these legends and also these colors, we can see, for example, places where we have the really low velocities and also places where we have these really high pressures. And the only logical solution would be to place a pressure reducing valve here to this node. So let's do it. First of all, I will delete all these theme maps from the drawing, and also I will delete these pressure contours. And let's go to this node here. I will go back to Wetplan panel, hydraulic node equipment, and here in this node here, I will set one pressure reducing valve with the reduced pressure setting of 35 meters. So now when I click apply, notice that the custom block will automatically appear, but the value didn't change automatically. And this is because we have to rerun hydraulic calculation. And now I will not go to pipe optimization anymore. I will go to hydraulic calculation according to existing pipe diameters. And all I have to do is just click calculate, save, and now you can see that all the data in the data tables and also in the labels automatically changed. So now we have this pressure dropping here to exactly 35 meters, which can also be seen in the profiles. So because of this pressure reducing valve that we defined in this node, we can see this pressure drop happening in this node here. Okay, the next thing that I would like to show you is how to define water demands for firefighting. So again, let's go to water demands. And basically defining firefighting demand is like defining point demand, which is basically very similar. So just go to selection of the nodes, and now you can select one or multiple nodes. I will select just this last node of the system, and directly through the data table I will set 10 liters per second for firefighting demand in this node here. So basically you can create any amount of these water demand definitions or consumption categories or whatever you want to call them. And later on you can create so-called scenarios or water demand alternatives and group these previously defined consumption categories. So I previously defined these two water demand scenarios. One is with fire, where I have all the demand definitions turned on, and I have one without firefighting demand. So you can create any amount of these scenarios, and then you can go to scenario preview, and here you can basically perform parallel hydraulic calculation for multiple scenarios. So here we have with fire and without fire, and you can compare the results by looking all the data of one scenario and then all the data of the other scenario, or you can compare it like this, data by data, scenario by scenario. So we have flows, we have velocities, we have hydraulic losses, and also we can go to a default data table for the node results, and you can see water demands, head elevations, and pressures. And like I said, all this content of these data tables for basically all the data tables in Softplan, you can select the content, you can easily copy it, and you can go to Excel or any other Microsoft application, and you can get these really nice reports showing you all the data calculated in Softplan. Okay, so I will close now Excel and also this dialog, and now I will switch to the third drawing, which is the last drawing, and you can see that again, very same network, but I added additional part of this network, this part here, and using this hydraulic node equipment function that I already showed you, I defined one reservoir here in the starting point, and also I defined one pump here in the second node of this network. And this will be the pipeline from the pump to the existing tank. And this same part of the network can be seen here in this profile. So we see the reservoir, we see the pump, and this very steep terrain that goes to this water tank. Additionally, what I defined in this drawing are time patterns. So let's open the function for curves and time patterns, where you can see this pump curve that I mentioned. So I just defined one simple one-point pump curve, but of course you can also define more complex pump curves, so 3-point or multiple point pump curves. And also I defined two time patterns, one for population, where I defined these 24 different coefficients of variation per hour with the peak flow happening from 4 to 5 p.m. And also I defined one firefighting demand time pattern with one firefighting happening and lasting for 2 hours during the peak flow of the population, so from 4 to 6 p.m. Okay, so now when we have time patterns defined, I also defined some rules to control the work of this pump. that I will show you now. So just two simple rules. So this rule, pump off, which says that if water level in the tank is equal or higher than 5, then pump status will be closed. And the second one, which says that if the water level in the tank is equal or smaller than 1, then pump status will be open. So that's it. We have everything ready to go to hydraulic calculation. So let's open it. And now, because we defined those different scenarios, now you can choose according to which scenario you would like to run the hydraulic calculation. So you can select one of these defined scenarios, or you can go sum of all defined demands, which for this example here is basically the same as with fire scenario. Before I click calculate, I will go to options dialog, where you can see all the EPANET available options, including this demand model, so demand driven or pressure driven analysis, which means that we are working with the latest version of EPANET, which is 2.2. The only thing that I will change here is the total duration. I will change it from 0, which is a snapshot hydraulic calculation, to 24 hours time simulation. And now when we click calculate, and I didn't say this before, but each time you click calculate in Wetplan, this IMP, EPANET IMP file is created. So if you need it, you can open it directly in EPANET or any other hydraulic modeling software. You don't have to have EPANET installed on your computer at all, because the EPANET engine is already built in Wetplan software. But if you want, if you need, you can basically open it, and you have the same network here with all the data defined. So we can see these demand categories, we can see this base demands and time patterns, everything defined in the Wetplan. So like I said, I don't need EPANET at all, so I will close it, and I will save these results. And now you will see that I don't have just one set of result anymore. I have 28 sets of result, and using these time-dependent data tables, you can check the results by going through time with these arrows, or selecting some specific time from the drop-down list. Or we can switch to time preview, where you can see for just one selected element all the results of the time simulation for that one time period. So for example, let's select this first section right after the pump, this one here, and we can see that from 218 to 818 we have the flows and velocities 0. And if I switch to data table for the nodes, I can see for the pump that during those same hours our pump is closed. But the best way how to analyze these hydraulic modeling results is always by drawing some graphs. So here you can select up to 2 data. So for data number 1, I will select pressure, which for the water tank is basically water level in the tank. So I will select the water tank. And for data number 2, I will select section velocity, and I will select again this section right after the pump. And now we can see on the same graph how the water level in the tank is rising until it reaches the maximum value. Then we see that the pump is closed and the water level starts dropping until it reaches the minimum value, and then the pump is back on and the water level in the tank is rising again. If you need, you can draw these graphs in CAD. So you can draw it like this, that you have all the values on the same graph, or you can draw it like this, where you have each value on a separate graph. Also, one really nice way how you can check these time-dependent results is by using these time-dependent labels. So if you open set time function, again you have these very same arrows with which you can go through time and see the results in the labels. Or you can also go to profiles here and check the results using these time-dependent piezometric lines. You are controlling it with the same function. So let's go to 4 o'clock, which is our peak flow, when we have that firefighting time pattern turned on. And now I will just click apply time So those values are now saved in the drawing. So you can see these piezometric lines, and also we can see these values in our permanent labels. Okay, so that would be it regarding the hydraulic calculation and hydraulic modeling. And let's now switch to something completely different, and that is the trench excavation calculation and reporting. So to be able to do that, we have to first define the trench. So let's go to input data, trenches, and from the trench catalog, you can choose and create many different types of trenches. So it can be a single trench, it can be a double trench. With step, you can use the trenches with sand bedding or concrete bedding, different slopes, different sizes, and so on. So I will select the entire network, and I will set this single trench with sand bedding with the 90 degrees angle of the sides with formwork. So let's click Save. Of course, you can also define different trenches for different parts of the network. The next thing that I would like to define is the so-called top layers. So basically the type of the top soil or layer under which your pipeline is going. So again, in the catalog, you can define different types of these top layers. And first, I will set 2 layers of asphalt, total 15 centimeters, to the whole network. But because my pipeline is not going everywhere under the road, I will additionally select, you can use from node to node selection or from station to station selection. I will select from the beginning up to this point where our pipe is, we will see here, where our pipe starts going under the road. So this would be this station here. I will change the type of the top layer to humus, which is basically earth material. So let's click Save. Okay, and this can be best seen in the profiles. So let's go to Profile. And now you can see that we have this trench defined, which we can see by this sand bedding. And also you can see that we have 2 types of the top layer. So up to this point, we have 2 layers of earth material. And from this point on, we have 2 layers of asphalt. This can also be seen very nicely if we draw some cross sections. And to draw cross sections in Softplan is really easy. Basically, just like drawing the profiles, you have your cross section configurations, and everything is stored in those configurations. From scale to colors to data to basically everything. So I will intentionally use this configuration in a little bit larger scale, 40:1. And now you can interactively select some stations in plan or in profile where you want to have cross sections, or you can do it automatically according to arrays or branches. So I will select this array and this array here, and I will have a cross section each 25 meters. And now you see it will be total 55 profiles or cross sections, and let's just draw them here. So in a matter of seconds, with just one click of a mouse, we have these 55 cross sections, and we can check them. They look really nice. And like I said, all these hatches, all these dimensions, all these colors, and also the data. So we have this really nice data. So for each layer, you have the cross-sectional areas, and everything is defined in this cross-section configurations. So basically, you can create them once and use them on all of your projects. So now that we have this defined, we can also create the excavation report directly to Excel. So let's select the entire network. I will group report by arrays. And when I click Save, in a matter of seconds, this Excel report will be created, and we can open it directly from the software. And here you can see for each section, you have starting and ending stations, total excavation volume for the entire section, excavation volumes according to depth excavation zones, which can be set up by the user, but I use the default, which is from 0 to 2 meters, from 2 meters to 4 meters, from 4 meters to 6 meters. Also, you have all the volumes of the top layers, sand bedding, pipe volume, all the volumes of the backfill layers, formwork area, and top surface area of the trench. And the report is grouped by arrays because that's how we defined it. And if we scroll to the bottom of it, you have what is most important, and that is sum of data for the entire system. Okay, and the last thing today would be creation of 3D BIM model and exporting to IFC. So to create a 3D model in Softplan is basically just applying of a different style. So I will switch from 2D style to 3D style, which is basically change the visual appearance of my network from the lines and blocks of BricsCAD to 3D solid elements. And now you can see we have these pipes, we have the manholes, everything is in 3D. Also, we can draw the trenches in 3D if you want, but it's very important to say that the level of details, level of development, LOD of the Softplan model is 300, which means that we draw the pipes, manholes, and trenches in 3D in, of course, the right dimensions, but we do not draw appurtenances and pipe fittings in 3D. Okay, and now let's export this to IFC. Okay, to do that, let's switch to our BIM panel, where you have all these commands for exporting to various BIM file formats like IFC and Navisworks NWC. You can also import and export to LandXML, but let's use IFC. And here in this dialog, you can choose first what you want to export. So I will export the network and also the DTM surface. And also you can define which data or groups of data you would like to export with your model. So I will export geometry data, excavation data, and water hydraulic data. And it is important to say that you can create these groups of data for export once and then use them on all of your projects. So now when I click export, in a few seconds this IFC file will be created and you can open it in any BIM viewer. And I like to use this free software, which is BIM Vision. And here we can see the DTM, but I will hide it so we can focus on our pipes and manholes. And here you can see everything looks really nice. You can see all the groups of data, so excavation data, geometry data, water hydraulic data, and also for the pipes. So even this water hydraulic data calculated with Wetplan and EPANET, so this basically modeling data, you can have it in your 3D BIM model. So that would be it for today. I hope you liked it. I hope you would like it to try it and test it on your projects. And now before we go to Q&A, I will give a final word back to Michael and Sean. Thank you all.
Yeah, thank you for that. That was extremely impressive stuff. It's actually my first time seeing the software in full detail. So it's very impressive how mature it is and very impressive how complete the workflows are. So
Thank you.
I think, yeah, we'll just use a few minutes for some Q&A. What I often find is that people have questions after the event when they've had time to process. So when those occur, please get in touch with us and we'd be happy to get back. I also believe this session is being recorded, so the recording will be made available as well. We've had some messages about that.
Sean, should we run maybe some polls before we go to questions?
Yes, of course. Let me see if I can run them from here. So let's run a quick poll here just to get your feedback on the general BricsCAD Softplan solution. So is this poll working at this stage? Okay. So we have some good feedback here. We've got a bunch of people who want to have more in-depth discussions and some people who are quite impressed with the solution as it is. So Great. Then the other poll we wanted to run is really more of a entering questions into the Q&A tab. But we're interested in knowing what kind of work you do in general in the overall water networking area or extended areas beyond that. So it gives us a bit of a taste of where we should do future webinars. 'Cause we're quite happy to keep on doing these sessions, but it's always better if we get some feedback on what people find relevant. So that's great. We'll take those votes on board. And if anybody has got any feedback on the general areas that you work in, it's great if you can type those into the Q&A tab. Okay. So we got a question here, guys, on how the system would be applied to stormwater drains.
Yes, so today we were showing the Softplan Wetplan module, which is for water distribution network design, hydraulic calculation and modeling. But we have basically a parallel module of the software, which is called Softplan, which is for the storm and sanitary networks. So you can use it for detailed design, hydraulic calculation and modeling of both gravity, pressure, and vacuum network, so both storm and sanitary is inside. And for hydraulic calculation and modeling, we are using EPA software 5.1, which is integrated into the Softplan, just like I was today showing you the this Wetplan module, which has the EPANET engine. This Softplan module has the SWIM 5.1 module, and also you can have what we call Softplan Ultimate package, which contains both modules and also some additional modules as well.
Very good.
If I can just add a little bit, just 2 points. We also have the rational method. Some people sometimes ask me, is it only swim? No, there is a rational method, let's say the easy design and also swim. And the second, maybe just to the question was how does this apply? Well, probably 80 or 90% of the software is the same. So you actually use the same commands to design in layout, design in the profiles, the cross sections. So all of these things are virtually the same. The catalog for the pipes, for the manholes, for the trenches, and so on is the same. And it's the same process to add the pipes, edit pipes in the catalog and so on. So it's always the same workflow. There's only the difference, like Rino said, regarding hydraulic calculation. And okay, there are some minor differences because pressure pipes is not the same as gravitational pipes, but in general, it's a very, very, very similar. If you learn how to do one network, you essentially know how to do the other network.
Fantastic. We've got quite a few other questions. Some of these might be a bit too technical to go through today, but one of the more generic ones is about evaluation licenses. So
Yes.
Is there a process for getting an evaluation license and getting a little bit of a head start on how to get going?
Yes, of course. So you need to please just get in touch, leave your email and contact data so that we may reach out to you, and then we will send you the trial license, which is free, of course, and also access to manuals and learning materials and so on. And also during testing you have access to our tech support system, so we can help you with advise you with licensing and installation, and then also using the software.
Yeah. And for the guys who are typing in the questions, we have your details from the questions, so we can pass those on to Mikhail and the guys for those. So some of these questions might be a bit more in depth. There's a question about which formula is used to determine the frictional head loss. Now, that sounds like a cool question. Do we have time to go into it?
Basically, the answer is very simple because everything that you saw regarding the detailed design, so the drawing in plan, drawing in profiles, drawing, the everything is what basically we are doing, and everything regarding the hydraulic calculation is being done by EPANET 2.2. So basically, we are just sending the input data as EMP file to EPANET engine. EPANET is calculating in the background and is sending the data back to your familiar BricsCAD environment for visual analysis through data tables, through maps, through the profiles, and so on. So regarding all the equations, basically like it is done in EPANET, it is done with Wetplan, and basically you have in the options dialog, you have the possibility to choose between 3 different head loss formulas. So Hazen-Williams, Shazi-Manning, or Darcy-Weisbach. So that I think that would be the shortest answer.
Yeah, that's a pretty complete set of offerings. So we've got a request to do a webinar on the stormwater drains, which we'll definitely set up. There's also a question on how the system would work for cooling water network.
So basically, the software is meant for design the water distribution network and storm and sanitary networks, both gravity pressure and vacuum. It is not meant to use for different types of infrastructure, but of course you can use it. You create the new system type and you rename it to cooling water or heating water or whatever. But you are limited to the functionality that you have for designing these other these systems which are meant to be used. So you have your pipes, you have your manholes, you have your trenches, you have your functions for detailed design in plan and profile. You have functions for interactive or automatic definition of the pipe invert. But I don't know if there are some specific, because I'm not familiar with that type of design. If there are some specific rules or specific objects that happen in this cooling water, then probably no. But if it's basically, you can use Softplan for all the underground pipe utilities. That's the most general answer. But what it is really meant for, and for what you have all the hydraulic calculations, are water distribution, water, storm and sanitary, and also I didn't mention, but also gas. But for gas, it is only detailed design without the hydraulic calculation.
Okay, yeah, that makes sense. There's another question. Really, it's kind of asking about the utilization of water gems and Softplan, or kind of how they interact together.
Yeah, basically, water gems is software that, to our opinion, it's basically not competition software. It's a software that can be used along with the Softplan, because basically the main purpose of Softplan is detailed design. So you have, and basically in this 45 minutes I showed you really small amount of functions, but you have really detailed and specific functions for detailed design in plan, in profiles. You have a lot of different possibilities regarding plan labeling, the plan styling, the profile labeling, the functions for plotting, for creation of detailed design drawings. And of course, you have hydraulic calculation, you have a bit of, let's say, a simple hydraulic modeling. And what is a great thing is possibility to communicate with water gems, because we can, for water distribution networks, we can both import and export EPANET EMP file, which is possibility to import and export to water gems as well. And regarding the storm and sanitary networks, we can export the EPA swim IMP file, which can also be imported to sewer gems. And in the next version, which will come out by the end of this year, we also developed the possibility to import the EPASwim IMP file, which can also be generated in sewer gems. But also, not just IMP file, you can communicate with the S3 shape files. So we can also import and export shape files, and also water gems and sewer gems can import and export shape files. So basically, in my opinion, some ideal way would be to start your project in Wetplan or Softplan, so basically Softplan, do the detailed design, do pipe sizing, do some you can define the catchment areas, you can perform some hydraulic calculation, and like I said, even modeling. And then if you need that really high level modeling, which is really I would say high level, then without a problem export it to IMP or to shapefile, and then you can continue basically seamlessly in sewer gems or water gems for very advanced modeling and analysis.
Perfect. Yeah. It's good to see how mature the overall package is. Okay. Well, we can have some more questions if you guys got them, or we can just leave it there, and we'll get back to you guys with any other queries you have, and we'll also make sure the recording is available. There's been a few more kind of likes and endorsements of having the stormwater and wastewater webinars, so I think we'll definitely discuss those. There's one more question. Can you design water, wastewater, and stormwater in parallel so they can be modeled together? So showing common trench details and cross sections, etc.
Yes, we have. This is also additional module, but when you buy that package that I said, which is Ultimate, and then when you have the water and storm and sanitary modules, you also get this special module. We call it geodesy, but also it's meant to. Okay, you can do some surveying functions and basically geodesy functions, but the great feature about that module is that you can design alignments, and for those alignments you can draw cross sections, which are basically very similar like road design cross sections, and in those cross sections you can see the real terrain elevations. You can show multiple terrains, and you can show multiple pipelines, and you can basically parametrically design trenches for multiple pipelines. So if you have, let's say, 2 or 3 or basically any amount of pipes that are going in the same trench, you can design that, and then you can also run the excavation calculation report and get all the quantities of the excavation and all the backfill layers for that complex multi-pipe trench.
Just a quick addition. If you are planning on using the software mostly for design and hydraulic calculation and analysis, then the standard versions are okay. If you are planning on using these more advanced features like this trench for multiple pipes, or if you really need to heavy go into data import export, with Google Maps, with shapefile, with IFC and all this stuff, then you probably need the Pro version or the Ultimate version. So the Ultimate version is essentially everything for water and everything for sewage combined into one. Okay, but we don't need to go into details right now. We can, anybody can just ask directly, and we are happy to answer. And also, I think the very first question, was about the software, so where it can be found. So you can find it on the BricsCAD store. So let's see if I can. Yeah. Okay. So so if you go to the BricsCAD if you go to the BricsCAD website, you can go to application catalog. Okay, and then once it loads, the easiest way is just to click on civil. So you get all the civil applications, and there you have it, Softplan Ultimate. Here is just the Ultimate version because it's it's everything. But of course you can get the detailed version just for water, just for sewage, and the descriptions and some additional information in the PDFs, including how to install it and activate it. And you can download the trial right here. Okay.
Excellent. Okay, so there's a question about urban OSARs. I'm not familiar with these names, but the question is if urban OSARs and Softplan work together.
Yeah, essentially it's the same. Yes.
Okay. Very good. Well, we'll stay online for a little bit longer, so if there are more questions, please ask them. Or if we don't get to answer the question now, we'll definitely get back to you on email in the next few days. So thank you everyone for attending. Thank you for the amazing presentation, guys. And we look forward. We'll definitely set up the wastewater, stormwater one, and yeah, we'll get some more feedback and keep them going.
Yes. Thanks everybody for joining us.
Thank you very much.
Cheers, guys. Thank you.
Bye bye.